In the previous lessons, you learned all about right triangles, some of the special properties, how to find sides. You also learned how to start using trigonometric ratios. Today, you're going to use those ratios to find missing angles and missing side lengths in a triangle. These are actually day 4 notes. We keep on rearranging the unit. When we say solve a right triangle, we want all the unknown sides. We don't know the measure of angle A. We don't know the length of side A or side B. I'm writing those down so I can keep track of what I'm actually trying to find. Okay, now let's take it in the order we have in the notes. I am going to label the missing vertex B. It is opposite side B, so it is capital B for the vertex. Okay, let's solve for the sides first. There's no rule that says you have to do this first. We just happen to teach it this way. So let's look at what we need. Well, let's look at what we know. We know the angle. The angle is 58 degrees. We know the hypotenuse. The hypotenuse is 20. And the missing side we don't know, A or B. We don't know the adjacent and we don't know the opposite. Well, let's write some things up top to remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And I say this in my head. I say so katoa in my head to make sure I write it properly. You just get so used to it, it'll flow. We decided, since we knew the hypotenuse and we were solving for the adjacent side, use cosine. Let's do the math. We set up cosine 58 equals A over 20, adjacent over hypotenuse. To solve for A, I'm going to put cosine 58 over 1. That way I have two ratios. It's easier to cross multiply when you have two ratios. All right, so I get A equals 20 times cosine 58. Now I've already checked to make sure my calculator is set up for it's in degrees because I'm inputting degrees. You will not get into radians in basic geometry. You'll get into radians later in pre-calc and trig. All right, so cosine 58 goes in my calculator, and I have that, and I multiply it by 20, and I get A equals 10.59838 ... I'm rounding to the nearest tenth. Remember it said that up here. So A is actually going to be, side A, 10.6. Okay, I'm going to write this down, 10.6, because I have just found it. Now we're going to solve for side B. We can still use angle B. We can use 58 degrees. Well, now we can do it two ways. I recommend when you solve these, you use the original given information. You do not use the numbers you find. If you use the original given information, you've got a much better chance of being right. And just in case you had a rounding error in your answer, you won't take that rounding error and put it into another problem. So let's do side B. We still have 58 degrees. B is opposite, side B is opposite, and hypotenuse. That gives us sine. Sine 58 over 1, cross multiply. B equals 20 times sine 58. Okay, handy dandy calculator again. I'm putting in sine 58, and then I'm multiplying that answer by 20, and I get B is 16.96096, etc. Round to the nearest tenth, which means B is 17. And go ahead and put 17.0 because 16.96 rounds up to 17. All right? Think about that. Those are always fun. Now solve for angle A. This is the easiest part of the equation. How many degrees are in a triangle? 180. We know the right angle is 90, and we are given the angle 58. That equals 148 degrees. 180 minus 148 is 32. 32 degrees. So with doing a little bit of sine and cosine, a few trigonometric ratios, and you can solve for every bit of the triangle. You are given two pieces of information, one side length and one angle, and you could do the rest of it. So that's pretty awesome. All right, now we're gonna do another one. And here we wrote down what we're looking for. Now I'm gonna do it a slightly different way. Same math, I just want to switch it up a little bit. All right, I like to do the easiest thing first. If I know, and I'm going to go ahead and mark that A, I know A is 56, and I know the right angle is 90 degrees. Well, let's put over here. 90 plus 56 equals 146. 180 minus 146 is 34. So I know angle B is 34 degrees. That was just really easy to do, so I went ahead and did it. So angle B is 34 degrees. Now, let's solve for side B, okay? Side B, I'm going to use my given angle, A. Now, side B is adjacent to angle A, and 26 is the opposite opposite side to angle A. So what trigonometric ratio uses opposite and adjacent? That would be tangent. So I'm going to say tan 56 equals opposite, which is 26, over adjacent, which is B. Put it over 1 to cross multiply. I get 26 equals B times tan 56. But that's not what I want, is it? What I want to find is B. So I'm going to solve for B. It's another algebra step. It's not a big deal. Divide both sides by tan 56. Because tangent 56 is one unit. You don't separate it. Tan 56. So now I have my second and final step, 26 over tan 56 equals B. And now I just plug numbers into the calculator, okay? I'm going to plug in 26. I'm going to divide it by tan 56. Again, tangent 56 is one thing. No extra parentheses required. It's one operation. And that gives me 17.5372 ... Rounding, B is 17.5. Okay? Not so bad. Now let's find side C. And let's label some steps here. We're going to go B, and this is angle B. There we go. And now we're going to find C. I'm simply labeling what I'm doing so you can keep track of the equations. All right, I'm going to use angle 56 again. I know the opposite side is 26 and the hypotenuse is C. Okay, so we are going to do sine 56 equals opposite over hypotenuse. 26 over C. Put the 1 to make them two ratios, cross multiply. 26 equals C times sine 56. Divide both sides by sine 56. And I get 26 over sine 56 equals C. Time to plug in my calculator. 26 divided by sine 56 is 31.3166. So C is 31.3. So what you did, I showed you basically two completely different ways to solve things, but using trigonometric ratios. In the first triangle in blue, our ratios were set up so our variable was on top, and you went immediately to A equals 20 times the other side. In this second triangle, I used the original angle, and our variable ended up on the bottom. So I cross-multiplied, and then I had to do another division step. There's nothing wrong with that. If you want to, you can do it a little simpler. You can use the measurement for angle B, which would be 34 degrees. And I'm going to show you. You may think it's a lot of information, but I really want to give you options. I want you to understand different ways to do things. I'm going to find C. No, I'm going to find B, side B, okay? Because I can. So angle B is 34. I'm just going to write it here because we know that. There's nothing we can do wrong with that. It's not a rounding issue. It simply is 34 degrees. So let's look at this. If I want to find the opposite side, I have the adjacent and the opposite. I can do tan of 34 equals opposite, which is B, over adjacent, which is 26. Again, 1 and cross multiply. B equals 26 times tan 34. Can't get any calculator. 26 times tan 34. B equals 17.537 dot dot dot. 17.5. Okay? Let me erase that. And I'm going to put this as B. So you can do it either way. Okay, here's the left side is finding tan 56 equals 26 over B. The right side is using tangent 34 equals B over 26. It is your choice which ratio to use based on which sides and angles you know. I know that confuses students sometimes. There is not just one way to do this. There are multiple ways. So I've shown you a couple of ways. Let's go to the next page. All right, on this page, oops, again, still day 4 notes, not day 5. We're going to set up a trig equation to find the angle measure in a right triangle. And if you notice, we only have the 90-degree angle marker, so we know there's one angle of 90 degrees, but we don't know the measure of the other angles. So we cannot just subtract something from 180. We don't have enough information. So we're going to set up a trig equation. Now, why do we need to use cosine? Well, let's write our little hints up here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We use cosine because let's look at our triangle. We're finding the measure of angle X. We have the hypotenuse and we have the measurement of the adjacent side. So all we know are A and H. If we know A and H, we're going to use cosine because we know the lengths of the hypotenuse and adjacent sides. So that's why we chose cosine. It's the one that works. Now, when you've got cosine x equals 9 over 13, you do not cross multiply. This is even easier than that. we're going to do something called the arc cosine. The arc cosine is sort of kind of in an inverse. I'm not going to get into the trig and details, but if you are using your Alex calculator, you're going to click on the button that says that shows cosine to the negative first power, and you're going to put in your ratio, 9 divided by 13. That's what you're going to do. Put in your ratio. Equal sign, and you're going to get 46.18693 ... We want to round to the nearest tenth, 46.2. Now, if you're using a TI or something like that, even the simple scientific calculators we have in the classroom, you're going to hit the blue second function button, and you're going to look for the sine, cosine, and tangent buttons, and the blue one will give you arc sine, arc cosine, and arc tangent. The Alex calculator is easiest only because they're separate buttons, but you are going to get the exact same answers no matter which calculator you use. All right, I want to add something. I want to find the measure of angle Y. It's not a requirement, but why not? Let's practice. All right, so the sides we know in relation to angle Y are the hypotenuse and the opposite side. Well, the only ratio that works with opposite and hypotenuse is sine. So we want sine Y equals opposite, which is 9, and hypotenuse, which is 13. Y equals arc sine 9 over 13. Same concept. Plug it into your calculator. 9 divided by 13. You are going to get a different answer, guys. Not when you don't do the right function. 9 divided by 13. 43.8 degrees. Now I'm going to show you how to check this. What is 43.8 plus 46.2? 10, carry the 1, 0. It's 90. Well, 180 minus the 90 we know is 90. 90 equals 90. We have the correct measurements. That's kind of a little check you can do. It's a very simple way to check that you did something right. If you get an answer that doesn't add up to 90 degrees, and I say 90 degrees because we always have the right angle, which is also 90 degrees, then something's wrong. So that's a little check you can use. Let's do the next one. Let's find x. Okay? Now looking at x, in relation to x, we know the opposite side and the hypotenuse, which means we're going to use arc sine. Sine of x equals 7 over 13. So x equals arc sine 7 over 13. Plug it into my calculator. I'm going to use the Alex calculator this time. Arc sine, and it pops up with the parentheses, which is nice. 7 divided by 13 is 32.57897. I want to round to the nearest tenth. X is 32.6. Okay? Now, again, grins and giggles, let's find angle Y. I still know two sides of my triangle. I know the adjacent and I know the hypotenuse. So this time I want to find cosine of Y. It's still 7 over 13. Y is arc cosine 7 over 13. Plugging it into the calculator. Arc cosine 7 divided by 13 is 52.4. Let's do my check to make sure I did this right. 52.4 plus 32.6. Oops, that's 57.4. Sorry guys, I can't read my own handwriting. That's 57.4, which kind of makes a difference. If you're anything like me, most of your errors are going to be transcribing from what you see to what you write. All right, 4 plus 6 is 10. Carry the 1, 0, 9. It's 90. That's what my goal was. All right, so I did it right. Now, we're going to use trig to find angles of elevation or depression. Now, an angle of elevation, and I'm going to write a little bit that I may have to erase it. Elevation means going up. The angle is going up. So therefore, depression, an angle of depression, going down. We're usually going to provide the pictures, but in case we don't, you need to understand what an angle of elevation is and an angle of depression. An angle of elevation is when you're standing and you're looking up. You're looking up at the sky. You're looking up at the trees across the street. That is the angle of elevation. An angle of depression is when you're standing and you're looking down at the sidewalk. Your angle is going down. All right, let's do the math. You're finding x, the angle of depression, from the top of a lighthouse that is 179 feet above water level to the water line of a ship that's 1,114 feet from shore. All right, we drew the picture. So here's the angle of depression looking down from the lighthouse. I'll even do it in yellow. Our angle of depression is x. That's what we're trying to find. The top of the lighthouse is 179 feet above the water, so that's our opposite side. And the distance from the lighthouse to the water line of the ship is 1,114 feet. That is our adjacent side. So we know adjacent and we know opposite. There's one ratio that uses adjacent and opposite. That is tangent. So tan of x equals opposite 179 over adjacent 1,114. So x is the arctan of 179 over 1,114. The math on this is easy because you plug it into a calculator. What you need to be able to do is set up your problem. So arctangent of 179 divided by 1,114 is, again, we're going degrees, 9.1 degrees. All right? 179, yep, that's it. 9.1 degrees. Now what I like to do, as you know, I like to find the other side just to make sure I'm right. So let's find, I'm going to do this in green, the other angle, the angle of elevation from the waterline of the ship up to the top of the lighthouse. Okay, I'm going to do this in green. We know the adjacent, which is 179, and the opposite, which is 1,114. So y equals arctan, but this time you're adjacent. Let's see, it's opposite over adjacent. 1,114 over 179. And that gives me y equals 80.9 degrees. And like I like to do with my check, 9.1 plus 80.9 is 90. So there's my built-in check to make sure my angles make sense. If they don't add up to 180, I did something wrong. All right, good luck working with this. You'll do fine.